Okay, today's going to be a bit of a challenging day. We've got a long block and we've got a lot to get through. So let's go to it. I'll pause here while you read this, or I'll let you pause. So basically, we're trying to figure out a formula that can always be used to solve an equation if it's given to us like this, or if we can change it like this. So any quadratic formula, because we can always set it equal to 0. Okay? And we're going to discover it ourselves. Aren't you excited? Okay. So we're just going to follow these directions. We're going to solve this ax squared plus bx plus c equals 0 by completing the square to find the values of x in terms of a, b, and c. So we're going to turn this into x equals something. Okay, so to help you clear up, I'm going to do it at the same time in green. Okay, so my green equation, I'm going to use 3x squared plus 4x minus 5 equals 0. Right? That's the same thing. All I've done is plugged in 3, 4, and 5 for a, b, and c. Okay, first I'm going to subtract c from both sides of the equation. So I'll end up with ax squared plus bx equals negative c. If I subtracted c, which would be negative 5 from both sides, I'll end up with 3x squared plus 4x equals 5. Simple enough, right? Now I'm going to multiply both sides by 4a to turn this ax squared into a perfect square. So each term by 4a. So I'll turn ax squared into 4a squared x squared. I'll turn bx into 4abx. And I'll turn negative c into negative 4ac. Now, for my green one, 4a is going to be 12, right? Because a is 3, so 4 times 3 is 12. So I'm going to multiply each term by 12, and I'll get 36x squared plus 48x equals 60. Now look, that 36x squared, now it's a perfect square. Okay? I'm going to add b squared to both sides of the equation to complete the square. Why b squared instead of half of b squared? Because we have a coefficient in front of x squared. Okay, so right now we're just trust me. We're going to multiply it by b squared. Or sorry, we're going to add b squared to both sides. So 4a squared x squared plus 4abx plus b squared equals negative 4ac plus b squared. And now we can take this, we can factor this. It's a perfect square trinomial. So we can factor it. What's the square root of 4a squared x squared? That's going to be 2ax, right? We're adding. That means we're going to add the square root of b squared, which is just b. Okay. So if we multiplied this out, we would get this. Equals, and all we did on this side is we just turned these around. B squared minus 4ac. Okay, so there's my green one. I had 36x squared plus 48x. To complete the square, I added b squared, so that's 16 to both sides. Because remember, my b is 4 over here. Way up here, there's my b is 4. Okay, so I added 16 to both sides. Factor this perfect trinomial into square binomial is 6x plus 4 squared equals 76. Okay, so now we're at the same spot. I'm going to rewrite my equations. There we go. Okay, so this is the last part that we had. You can see it right above at part C. Okay, apply the definition of a square root and solve for x. So what's the square root of 2ax plus b squared? Well, that's 2ax plus b, right? Equals plus or minus, because we're taking the square root, this, b squared minus 4ac. And now to solve for x. So I'm going to do the same thing over here. I'm just going to take the square root on each side. Again, plus or minus root 76. And now I'm just going to solve for x. So what I have to do, I have to subtract b from both sides. I'll do that over on my green side as well. Divide both sides by 2a to isolate x. Which there, I'm going to do it on my green side as well. And yes, I could keep solving from here, but I'm not going to. Here's the magic. This right here is the quadratic formula. So as long as you are given an a, b, and c, you could plug it into this and find out what x is. Woohoo! Okay. All right. So I'll let you pause and think your way through these before I give you the answers. Ready? You didn't give up easily, did you? All right, I'm trusting you. Okay, number 1a, why did we do that? Well, we did that to make the coefficient of x a perfect square. You could have just multiplied it by a to get a squared x squared, but it's a little bit easier if we multiply it by 4a. Okay, in part C, why did we add b squared? Well, we did it to make a perfect square trinomial. But since x squared had a coefficient greater than 1, it's more complicated than what we know how to do, so we just followed the directions. Yay for good directions. 1c. If the answer to this is positive, how many solutions do we have? Well, we have 2, because then you'd get both a positive and a negative square root, right? Let's say it's positive. Let's say this expression right here was equal to positive 9. Well, then when we took the square root, we would get positive 3 and negative 3, right? We would get plus or minus 3. And then when you did the rest of the math, you would end up with 2 solutions. If the expression under the radical sign, b squared minus 4ac, is 0, how many solutions would we get? And what if the expression is negative? So let's see. If that was 0, then we would be taking root 0, which is just going to be 0, right? There's no positive or negative. So we would have 1 solution, because then when we do the rest of the math, we're just adding 0, right? We don't need to add 0 and subtract 0, because it's going to be the same. What if that expression was negative? Well, then we would end up with no real solution. Because can we take the square root of a negative? No. And Josh, you can be quiet, but for now, no, we can't take a square root of a negative number. There's just no real solution. All right. Another method of deriving the quadratic formula is to first divide each term by a and then complete the square. So I'll let you work through this. So pause and then come back when you're done. Welcome back. So all we do is we're doing the math over here, and then we're explaining what we're doing. So here's our starting point. We subtract c from both sides. Oops, ignore that. We subtracted c from both sides. That's all they did to get from step 1 to step 2. Then we divided each term by a. So that turned into x squared plus b over ax equals negative c over a. Now what did we do in this step here? So you fill this part out. We added b over 2a squared to both sides to complete the square. Now we just factor the left side and write the right side as a single fraction. So we factored this perfect square trinomial into a binomial squared, and we simplified this side. So we got that. And now what are we doing here? Well, we're taking the square root on both sides. So we applied the definition of a square root. Okay. And then on this side, we're going to apply the quotient property of radicals. In other words, we're taking this, just like they did up here, root 5/9 is the same as root 5 over root 9. And that's what we're doing down here. We just separated these two parts. Okay. And then we simplified the bottom. We're simplifying the radical in the denominator because root 4a squared is equal to 2a. And then we just continued solving for x. All right. Before we kept going, I gave you a warm-up, so if you did not do this, go ahead and pause and do these. If you're short on time, at least do 1, 3, and 4. Remember your order of operations. All right. So in this one was pretty easy. We had x equals 7 plus 6 and x equals 7 minus 6. Oh, sorry, both over 2. So we had x equals 13 halves and x equals 1 halves. X equals 1 half. Okay. For 3, I just simplified what was underneath there. So I end up with x equals negative 7 plus or minus 3 over 10, which means I have x equals negative 7 plus 3 over 10 and x equals negative 7 minus 3 over 10. And when I do the math, I get that. And then number 4, again, I'm starting with simplifying what's underneath the square root. And I get x equals negative 9 plus or minus 5 over 5. Break into my two solutions. X equals negative 9 plus 5 over 5. X equals negative 9 minus 9 over 5. Simplify those. I get x equals negative 4/5 and x equals negative 14/5. All right, I'll leave these to you to practice if you really want to. So now what are we going to do? We're going to use the quadratic formula. Woohoo! So you've learned to solve quadratic equations by certain ways. I'll just let you pause and read this. Okay, so now what we're going to do is we're going to take an equation a quadratic equation in standard form, ax squared plus bx plus c equals 0. We're going to substitute the values of a, b, and c into the quadratic formula and simplify. And then we'll get our solution for x. So, but first we have some reflections. This one's a little weird, isn't it? First we have some reflections. So go ahead and pause and think about these things and then come back. Okay, so the expression under the radical, that b squared minus 4ac, is called the discriminant. Okay, so we call that d, the discriminant. So if d is greater than 0, how many solutions do we have? Well, then we have two solutions. We talked about that before, right? We have negative b plus root d over 2a and negative b minus root d over 2a, because this is negative b plus or minus root d, right? If d is equal to 0, then we have one solution, because there's no plus or minus 0, right? We just have negative b over 2a. And if d, the discriminant, is less than 0, we have no real solutions, because root d is not a real number, right? Then we would have negative b plus or minus not a real number. We wouldn't know how to solve. Okay, what if b is equal to 0? Well, there's a few different solutions. Typically, you would have two solutions. Root negative ac over a and negative root ac over a. Negative root negative ac over a. I'll get that right. Where did our 4 and our 2 go to? Where did our 2 go to? Well, our 4. Because what we did was we could pull that out. It just simplifies to this. Because root 4 is 2, right? And 2 divided by 2 is 1, so we can simplify that out. What if, however, b equals 0 and c equals 0? Well, then we only have one solution, which is 0. And if you think about it, well, if this was 0, then we would have 0 minus 0 over 2a. Okay? And however, we do need to know that if b is 0 and a and c have the same sign, then there's no real solution. Because think about it, then we would have the root of a negative number. If a and c were the same sign, we would have root negative ac, which would be a negative number, and we would have not a real solution. What are the solutions if c equals 0? Well, then we have x equals negative b plus or minus b squared over 2a, and x equals negative b plus or minus let me finish writing, then I'll explain. Okay, if c equals 0, then x equals still negative b plus or minus b squared, because that 0 part would cancel out. that that minus AC, right? Over 2a. Well, what's the square root of b squared? It's going to be just the absolute value of b. So then what we have is we have x equals negative b plus or minus b over 2a. So the two solutions are 0 over 2a, which is 0, or if this was if we subtract b, right, then we have negative 2b over 2a, which is negative b over a. Ooh, I'm not speaking well. Pause and review that as many times as you need. Okay, let's go on. So we're going to use the quadratic formula to solve the quadratic equation. First, we're going to identify a, b, and c. Check, make sure this is in the right order. In this case, it is. So a is 6, b is 5, c is negative 4. And then we're going to use the quadratic formula. So we're just going to plug those values in. So x equals negative 5 plus or minus 5 squared minus 4 times a is 6 and c is negative 4 over 2 times a, so 2 times 6. And now we're going to simplify it. 5 squared minus, so I'll do this on a piece of scratch paper, we'll end up with negative 5 plus or minus root 121 over 12. Evaluate the square root, we'll have negative 5 plus or minus 11 over 12. Separate into the two solutions and simplify. So x equals negative 5 plus 11 over 12, or x equals negative 5 minus 11 over 12, x equals 1/2, and x equals negative 4/3. All right. You can try this one on your own, or you can just follow along. It's up to you. I wrote it in green. I don't know why. So we have x squared plus 7 equals 4x. First, we've got to rewrite it in standard form. X squared minus 4x plus 7 equals 0. Identify a, b, and c. And then plug those into the quadratic formula. Careful, because one mistake here can sink you. Go ahead and try it on your own and then check before you keep going. Okay. So x equals negative 4 plus or minus root negative 4 squared minus 4 times 1 times 7 over 2 times 1. We'll simplify. We get negative 4 equals plus or minus negative 12 over 2. And, oh, the discriminant is negative. So that means we have no real solutions. Okay. Again, you can try this on your own, or you can just follow along. First, we have to rewrite this in standard form. 5x squared plus 14x plus 9.8 equals 0. There's a, b, and c. We'll plug these values into the quadratic formula carefully. Go ahead and try, and then press play. And then we'll simplify. Go ahead and try. And then we'll take the square root. Oh, look at that. Our discriminant is 0. That means we're only going to have one solution, right? Because plus or minus 0, right? So the discriminant is 0, so there's one solution. We just have negative 7 over 5. All right. Some reflections for you. Go ahead and pause, try them out, come back. So is it possible to have done it for part A by factoring? Yeah. Take a look. We could have factored 6x squared plus 5x minus 4 equals 0 into 2x minus 1 times quantity 3x plus 4 equals 0. And then we could have used the zero product property from there. Could we have solved the equation from part B by factoring? No. Because the factors of C, which is 7, don't have a sum of B, which was negative 4, we could have tried all night and we would never have gotten that factored. And is it possible to solve the equation of part C by factoring? Actually, yes. What we would need to do first is multiply both sides of the equation by 5. And then we would have gotten a perfect square trinomial. And then we could have factored that. All right. So these are just some practice problems. I'm not going to walk you through these. I'll let you pause and then look at my solutions. I just wrote this up here for reference. I had to rearrange first. I said I wasn't going to walk you through it, but yeah. All right, let's move on to the next one. Again, I'm just going to show you the problem, let you solve it, and then you can press play and see the solution after you try on your own. Why is there no real solution? Because our discriminant is negative. Third sample for you to try on your own. One solution. Why only one solution? Because our discriminant was 0. All right. See you in class.